And we're live.
We're live. Cool.
We are. Hi, everyone. I am Matthew to introduce you to a very special CanJS community hangout. We have a few people on the line. You all want to introduce yourselves? Oh, I'm Matthew, by the way.
I'm Josh. Hi. I'm one of the Joshes.
He is a Josh.
I'm the Justin.
The Justin. Very good.
I am the Brian.
And the Brian.
We're
Glad we
still
went with that. Glad we went with that as a theme. Like I said, this is a very special CanJS community hangout because all of them are special, I think. So this one's especially special. We're going to be talking about functional reactive programming and some of the work that Josh has been doing surrounding that, kind of seeing how that could play into CanJS in a future release. So with that, I think, Josh, I'll hand the mic over to you to talk about what you want to talk about.
Awesome. All right, let me the screen sharing thing. I like close hip chat. All right. There we go. Cool. Can you see my screen? Okay.
Yes.
Cool. So I want to talk about this thing, which is a kind of one of the, I'll say, compelling use cases for using something like FRP, and I'll talk about some other ones. I had a meeting with some folks this week and came up with even more ideas on the kind of cool stuff that you can do once FRP is available. So I'm calling it Candid Data View for now. Better names are more than welcome. But the main idea about this is you can create a can list, right? You have a can list that has like all your data in it, and you can create a filtered version of that list with a simple, what looks like a regular map filter function, and have the kind of let's call it the view. I'm calling it like these data views. Maintain itself whenever the source list changes. So if you have a list of to-dos, you can go ahead and maintain a list that's only the to-dos that are ready. So I have a example code. Yeah?
Oh, I was just going to, I guess, in order to understand this, how is this different from creating like a compute based off of a list?
So usually when you do a compute, you have to do what this is doing by hand. You have to figure out what change happened and then apply it yourself if you want minimal changes to some target, or you have to place them and recreate the entire array every time. So this tries to do the minimal number of changes based on the changes of the parent. It lets you maintain lists that are of different length on both ends, so you can actually output multiple values per source item in the array. It'll keep it in the right order. It'll expand them where they need to be. And more importantly, so this is what it actually looks like. This is from the tests. So here we create a source list, right? It's just a regular can list. And the way we create our filtered list is we call this toDataViewList method with a callback, and the callback is going to receive every item. It's going to map over each item in the source list. And then this map function is used to spit out results into the target list.
Okay.
If you call it at all. And it'll keep track of which indices generated what. So we can do essentially what a compute is. So this works like compute right here.
Right.
You so give the address on. Yeah, go ahead.
Well, I'm sorry, I'm kind of slow. I just want to go through this. So the toDataView list is going to take a function that the first argument is each to do, and in the map function, we call the map function with what?
You call the map function with the values you want to output.
You want to output, okay.
So let's say you want to return one value for each thing in the original. Let's say if we want one that's just synced, we would just do map to do, right? I forget about all this stuff.
So that would do all of them. That would
This would do all of them one to one.
Right.
If you want if you want 2 extra copies of the same to-do in the target list, you do it like this. So
It's
this
kind of
is
like a
going to
map,
have,
but every time you call map, you add something.
Right.
Mhm.
It's like a normal map function, except
It's like a map, except that you can call it multiple times. So
absolutely,
what's the-
or 0 times. So in
Or
this
0
case, this is
times.
also
well,
this is
zero
both-
times
Yeah.
times is just a filter returning false, basically, right? If you just
Exactly. So here's an example of both the mapping and the filtering. So we're going to have this structure for our to-dos, where we have a done flag, a description string, and the steps that you should take in order to complete the to-do item, right?
hey, Josh,
Yes.
have you thought about making it so if a return value could be passed to, just so someone could use it more like a map function if they wanted?
I do have that API, but I'm still working on it, and there's, because of the multiple return thing, it's a little trickier, and the fact that it filters as well. So I'm trying to figure out a good API for that, but I do have a version of that exists already, and I definitely want to do that.
Okay.
So
Yeah.
the target list is going to be a can list that is changes over time.
Correct. And so here we define what that's going to look like. So our target list is going to be only the pending to-do items, right? So we're not going to output anything if the to-do is done, right?
Mhm.
And then we grab the steps. If it's not done, we grab the steps, which is, as you see, an array. It's going to be turned into a list. And then we return as individual values each of the items in the steps. So what this essentially is going to do, it's going to flatten the steps into a single to-do list that is only the individual steps in the pending to-dos. So here's your task list based on your to-do list.
Okay, so this is really cool stuff. So it's not a target list is not a to-do list, right? It's a steps list.
Essentially, yeah, that's what it turns out to be.
Okay.
And so I can show you a bit how that looks like. So I have a source list. I think it's up here. Oh, sorry. I have it hidden behind a function right now. Oh gosh. Ignore this. I'm debugging stuff, and I forgot to remove that. So here we have our source list, right? You see it all. They're really all copies of the same thing.
Mm-hmm.
And then we have our target list.
I like that. Do the Batovi dance. It is
I like it too. Oh, oops, that's not a function. That adder. What did I do wrong here? I probably did something wrong. Oh, they're all done, of course. So here you can see source list .adder 0. So let's grab this guy. And you'll see that done is true. So let's do .adder. It's firing way more events than it should right now, and I figured out why, but I haven't fixed it, so pardon the spam. So let's set it to pending again, right?
Yeah.
Let's just pick one. Let's actually pick one somewhere in the middle. Let's pick like 5. And so we look at target list. And there we have only the steps for the 6th element.
Nice. Okay.
So let's do, we can also grab that, say, steps. And we grab the steps and we pop.
Hey, Josh,
Look at our
what is
target
target
list.
list? Is it a can.list instance?
Yes, it is a can.list instance. I am considering making it immutable, somehow forcing it to be immutable, because it's not really something you're meant to modify, but it is a can list.
Yeah, you could kill Asher and throw an error if someone tries to like do a set on it.
Yeah,
or
yeah,
push a pop or something like that.
I'm thinking about that. The thing is, the library that like hooks into all this goes through that adder itself, so it would break other things, and I'm not sure if it's worth it right now. But
we could move we could move some of Asher's stuff, so you can just call _get and _set directly.
yeah, that's the stuff I'm thinking of doing just to bypass that. But anyway, so you can see the target list is being, I haven't touched the target list. I'm only modifying the source list and the items in it. So let's just go ahead and let's do the first element. Let's go ahead and enable it. Done. False. And there we have it. So that thing is going to it's going to be maintained, it's going to be live, it's going to try and do the minimum number of changes in order to get the target list to work. Now the other thing about this is right now the API you're seeing looks like it operates on concrete existing lists, but let's say the plumbing and an API that is available means that you don't actually need to have a can list on either end of this. You can, for example, stream value events, change events, add, remove, splice, all these events from your server. Let's say you have a WebSocket connection. You can stream these change objects that can event stream created. So here's the FRP bit. So this is on Bitovi now. Awesome. Yeah. So any stream that this outputs, you can actually hook into this stream thing. So you can have, say, an enormous conceptual list of to-dos in your database, but let's say you're only streaming some subset to. Well, actually, let's say you stream the whole thing to the client, but the client doesn't keep it in memory. The client just picks and chooses the one it wants and keeps it in its target list. You know, stuff like that is what you can do, and you know, sky's the limit. It also outputs change events instead of simply modifying a list. So you can even do whatever you want them, filter those events, whatever you need to do.
Hey, Josh.
Yes.
Sorry, Matthew. Quick question.
No, go ahead.
Does it when the change events fire? Is it like after each transaction, or is it like, for example, if you go back to that code that you just had up?
Which code? This code?
Yeah.
Okay.
No, yeah. So if you called map multiple times in that to data view list callback, would it fire the change event for every new addition, just like normal can list, or does it do anything special to only get called once with each function call?
Let me see if I. So this callback here essentially becomes a compute, right? So whenever the dependence, I don't know if this is answering what you're asking. So whenever, let's say whenever to-do.add are done, or steps, or any of the things in steps change, right?
Mm-hmm.
This is going to rerun, but only for this one to-do. It will not rerun for all of them.
Yeah, this isn't going to cause any events because we're not manipulating any data here.
No, isn't that going to cause? So in this case, for your example, you've got two steps in your to-do.
Mm-hmm.
That will cause that would fire two change events, right?
Actually, it's going to fire one splice event.
Right. Okay. So if you were listening,
but it should be. It's also adding add and remove, right?
Okay. So this accepts add, remove, and replace.
All I'm asking, Josh, is if you
What?
were listening to target list is change event, would that be fired twice in this example?
Hold on. Oh, wait, I'm sorry, because here I'm trying to figure out if you're talking about firing the change event on the target list itself or on the source list.
On the target list.
Oh, what will the target list see? Well, it's going to get the add and remove event because this basically splices. You know what it does is this data view list.
It should get one add event, Brian, to kind of answer succinctly.
Yeah.
Why one? Why not two?
it's really going to, so what actually happens underneath is this becomes, so whenever this changes, it basically splices the results of this into the target list. So whatever that splice calls, whatever that splice decides to trigger, that's what's going to happen. So if it's like removals and addition, it's going to fire both events. If it's just a removal, it's like calling, you're basically doing target list splice.
Yeah, let me try to answer that to Brian. Because that function is converted into a compute, and it's just waiting for the result of that compute to change. The compute's value doesn't change until that entire function is run. So it's not like every time it calls map, we know it. We really only know the result of this function, essentially.
So it would only fire change once.
Yes, it should.
Essentially, yes. So this function will only collect the results and then fire a single event into the stream that kind of summarizes the one for this index.
Gotcha. Yeah, that's what I was expecting in 20.
So the cool thing about this, and I don't know if you already explained it, Josh, is but like even in to do MVC, when someone clicks in like a lot of the implementation of 2MVC, when someone clicks to change a individual to-do, that recompiles the whole list of to-dos that are like completed or inactive. Mm-hmm. Right? It's a compute. There's a compute that runs over all of them and gives you kind of a new list every time. I'm pretty sure every other framework does the same thing. I at least know that Angular is setting up a watch that when it changes, it kind of adds a new list, and then the live bind or the dirty checking sees that and updates itself. It's always recreating these full lists. With this, we can take something like to do MVC, and when you do filtration and things like that, you don't have to recombine all of these derived lists. It's just going to change in place these existing lists, which it should be much faster. Mm-hmm. So it's really, you know, if we get the performance running of this, which I don't know how it's going. You said there were problems. We haven't talked since then.
Yeah.
But if we get the performance of this, I mean, at least it should be better, much faster than recreating an entire list.
Mm-hmm.
I have a question going back to something you were saying earlier, Josh. You were saying making this immutable. Like, why wouldn't you? I mean, this is a nice way to filter. I would see, you know, filtering a to-do list, and I want to make the done ones or the incomplete ones be done, or something like that. That would not be a use case for this.
Yeah, then that's another reason why. Well, I'm not sure. The list itself would be immutable. Yeah. I don't think I would make the data structures inside immutable, because remember that there's a lot of magic going on underneath to maintain the items in the target list, and I feel like if people started like cutting the target list up itself, they would run into really weird effects.
So you're saying if I mapped to-dos within target list, I could modify those items in the target list. I just couldn't remove an item from the target list, right?
Right. You'd need to make sure that the target list itself stays unmodified.
Okay. Yeah, that makes sense.
You could, if you understood what's going on under the hood and you were ready to handle it, but recall that it might not be what you expect.
Not ready, Josh. No, it makes a lot of sense, because the structure is a function of your compute.
Right.
But the items you might still want to mess with.
And keep in mind that even if you do start expecting to do that, it's still tricky to change the data in target list. For example, here, in this case, let's say let's say the actual steps are objects themselves, and they might be different objects depending on how you did this function and how the implementation works underneath. So now you modify it in the target list, and then you don't actually see the changes anywhere else.
Mm-hmm.
So you do have to be careful even when modifying data structures in here. But it should be fine if you're just like mapping the to-dos themselves. Like if in the really simple case of just spitting out to-dos, that it's just like map to-do.
Right. But in this case,
would be safe.
You're returning everything that's not done So if I grabbed one event and marked them as done, the target list is going to recompute and not include that one anymore.
Right.
Right.
Josh, have you given any consideration to like the memory stuff? Like, how would you tear down target list and so that you can discard it?
Oh yeah, I mean that's the API for unbinding is there. Do I have it here yet? I wrote the unbind thing just for this. I don't remember if I actually added that in the end. La, la, la. No, I haven't exposed that yet, but yeah, I mean, basically, in order to have the target list no longer have an event hook into the source list, you're going to have to call an unbind or something similar. I know we were talking about adding that other method to CanJS. Where is that issue?
So does that make sense, Matthew?
Okay. Yeah, I guess I should explain. So now it should be fairly obvious that when you do this kind of automated data structure mapping, right?
Maybe
the
show your
target
code
list is
again,
going.
so they can,
Huh?
Maybe show the code again just so they can visualize.
Yeah. So this list. Where is it? Test. There we go. So this list, right?
Mm-hmm.
This list is essentially triggering a can bind into this, right? For changes into this list.
Mm-hmm.
Which means that as long as this list is observing and live, this list is going to be kept in memory.
Right.
Right.
Is that
Yes.
the way?
Yes.
It's target list.
This one doesn't know about target list at all, actually.
Yeah, it does. Remember, that's the problem.
Oh, right.
Yeah, it's as long as target list is listening, even if nothing can reference target list, source list still has an internal reference to target list.
Why does source list have a reference to target list?
Well, indirectly, although it's a circular.
Yeah. So it's a whole problem of event
Yes.
binding in general.
Yes.
Essentially, target list passes source list a event handler,
Mm-hmm.
right? And that event handler is called whenever source list changes to
Right.
perform some operations on target list. So that event handler can access target list.
Mm-hmm.
Mm-hmm.
So source list, by having a reference to the event handler, and the event handler being able to talk to target list, source list essentially leaks. As long as source list exists, target list will continue to exist.
Right.
So you need to be able to tell target list, when you're no longer used. So we remove your listeners from source list and also presumably from every to-do and potentially some of the steps, it looks like. The to-do steps at least. Whatever those computes, you've got to tear down all of those as well, presumably.
Yeah. So you would need to do something like, and I think this actually works with the new API already, but and then you'd need to grab the stream that does this, and actually just a plain unbind would do it, I think.
We talked about stop listening.
Yeah, stop listening, but right now that's the code still because we haven't added the stop listening to CanJS yet. There's a ticket for that, that's what I was going to show. So basically, it's a circular reference, essentially, so if both of them go out of scope, they'll both be collected, but as long as source list exists and target list is trying to do its mapping, target list is going to... That is a good thing to keep in mind.
I guess I'm not understanding completely. Like, what's different about this than just like a compute? If I had a compute against source list, wouldn't the same problem happen? But I don't have to tear down the compute manually.
You do. You are. Well, a lot of times the reason why you're not, when you have a compute, that compute is a lot of times associated with a component or a control.
Mm-hmm.
And that control is actually tearing down all that binding for you. Or the view, when the element's removed, if there's some live binding, it tears down the compute for you. So there isn't this association with source list. Now, there's two ways we could do it. Now, another option, and this is how async computes work, but I mean, Josh, we didn't really talk about this, but this is another option, is only by binding to a target list does it then suddenly enact this binding behavior, and then when the last unbinding happens, does it tear itself down? This is how most of the rest of CanJS works. Async computes are the same way. Async computes don't really have a value until you start listening to them.
Yeah, and that's actually not very hard to do. But
it's confusing to a lot of people. Like async computes have been kind of complained about, because people like, hey, why can't I read it? Why do I have to call something to get a value? So there's a trade-off that it'd be good if if people tweet us opinions or whatever, give us opinions on this. What makes more sense, right? Do you suffer the problems in the there's a trade-off. To me, it's like, well, you make people you can either make the library confusing, like async computes, to use, but then you're pretty much safe. Well, it's weird. Why doesn't it work right away? Oh, I've got to bind, but then you're probably your binding will probably automatically turn down, so you don't even have to think about memory. Or what you do is you burn people in the end. You say, oh, it's super easy to begin with, but you might be leaking if you're not careful.
Right. And I think this is also interesting because people might want to read this without using .adder because it's a list. And they might want to do it arbitrarily.
They shouldn't do CanJS. You shouldn't read from CanJS list without adder.
Right, they shouldn't, but they can.
Yeah.
And more importantly, I think a lot of use cases for lists do not involve attaching event handlers. So then what do? We start listening as soon as they do a .adder, and then we're leaking again because we have nothing when we should stop listening after the first .adder,
Yeah. No,
I don't know if
and to me, it's like, do we want to? To me, it comes down to, do you want to be popular or do you want to be right? And I think that this is going to be, like, for a demo purpose or someone just getting into it. Hey, this is awesome. This is so easy. This is going to be much more attractive to developers, where forcing people to do a bind or something like that is going to be
confusing.
Right.
And it's I don't know.
I think it's worth I think a note and documentation about it, and I also think the common use case for this, and we can probably find a way to add support to. No, it's tricky. Anyway, I think since the use case for this is very often to write filtered ones, people might start making really small ones a lot, and then they'd have to remember that. Yeah, I think the note might be okay. Because the other thing about memory leaks is, to an extent, you can get away with it for a while. And as long as it's clear to people that as long as we communicate it, put the thing there, they'll find the leak and go like, why is this leaking? Oh, call.unbind, and then, or stop listening.
Yeah.
And then it's fixed. As long as there's an easy fix when it actually becomes a problem, and we try and communicate it as early as possible, I'm not too worried about it.
One interesting thing will be, how does this work with the define plugin?
I was going to ask that.
I don't know.
Well, it doesn't do.
A lot of
it'll be important that it can.
I'm not sure what. Keep in mind, all this is doing. The only thing this is doing is it's hooking up the change events, interpreting them, and
a lot a lot of our code is just like we're filtering. We have some list of something and then we're filtering down inside of define.
So what I mean, Josh, is like the pending, the for to do MVC, right? I'd want to create a view model that, given a list of to dos, it has a pending and a completed method that is going to give me back, ideally, always the same array. It's never going to create a new one. It's going to give me back or I can call .at or pending, and it's going to give me essentially a target list from a source list. That would be awesome. That would be amazing, because then you can do things like associations, and you can solve a lot of like weird view model association kind of things elegantly, where right now the define plugin is great, but it always gives you kind of back a new item every time. This will allow you not to, but again, there's going to be kind of merging this into I'm gonna want to call, like, on my like if I have a we're gonna have to figure out how to do that transition to allow this kind of behavior, so I can have a pending attribute that gives back this target list. But then somehow I can stop the binding on it once that's gone. That's going to be the weird thing, I guess. I don't know.
Yeah,
but that's kind of what I would say is next for this behavior, at least.
And I think once we have a couple generations down in the browser, or even for evergreen browsers now, we can just start using weak maps, and that should take care of it too.
There's a polyfill.
Does it? That would be odd. Well.
Yeah, I mean, we are still going to need to make the unbind node, but at least on modern browsers, we can start shifting that way and say, oh, hey, if you use the latest Chrome, yeah, don't worry about this. It's been taken care of.
Yeah. I think I haven't ran that through in my mind, but if that's true, then that's awesome. Like, if we can solve this so you don't have to call these stop listening, that's fan-freaking-tastic.
Yep.
That'll change everything.
I'll have to think about it more to make sure that it's something we do want to do, because...
Well, if that's the case, though, like, it'd be great if you can, while you're working all this, take some time and kind of prove that out. Like, that's actually true. Then we should start shifting the define plugin, async getters, and everything else to work the way that you have to, like, okay, manually tear it down, unless you're using weak maps, and then you don't have to worry. And that would be amazing, right?
Yeah.
We kind of say, okay, yeah, fine, you might get memory leaks kind of easily unless you're using a great browser. But here's how you prevent it, but it's future-proof, right? I mean, you just don't know how much engineering time I've spent for CanJS trying to solve the memory leak issue. I mean, that's so much of the stuff inside of it is all just about memory leaks. Like, control was that, the memory, the model store, all of that. That, because of event binding, the two-way pointers in memory event binding. If that's gone, yeah, I think it is, but it's good. Sorry, it's a minor epiphany I just had.
There we go. That's why weak maps are magical, I hope.
Yeah. Oh, crazy. You just would have to put the functions, essentially, but you can't iterate through, though.
No, can't.
Ooh, I don't know then. I don't know if we can solve it, because you cannot. You need to get those functions. You need those functions to be able to disappear on the source list. You're gonna have all these event handlers, and you need those functions just to, like, oh, we don't know about them anymore. But you do need to be able to iterate through them.
Well, kind of. I mean.
Yeah, because you need to be able to call the event handlers back.
The other thing I'm kind of wondering is if there can be a callback on garbage collection of those weak things. Finalizers. Does ES6 have finalizers? Because that would be the other part of this equation. What we can do with weak maps, and I'm like 95% sure this is like easy to do, is we can remove the reference to target list. We can make it so target list gets collected. What we cannot do without finalizers is remove the handler when target list is collected. So that's a different step.
What is a finalizer? I mean, are you talking about
a finalizer is a callback that when a when a piece of data is collected by the garbage collector, it will run some callback in order to do cleanup. So it basically gets the garbage collector to do your memory.
Yeah, but that, I mean, that's, if that's coming, that's
I don't know if it is. I know about it from
map.
Other languages.
Yeah, the problem is actually I don't think weak maps solve it. Unfortunately, because you need to be able to iterate through that list of.
No. I'm not talking about using. I'm talking about using weak maps. Reference to target list. That happens in the event handler. So basically, what you'd have is you'd keep a weak map with a single value, that the value itself is the target list, and then you just refer to it through there if it's present.
But you need, no matter what, you need an array of all of the things in your target list.
No, I don't. I actually have no references to the target objects.
You do in your event binding.
Oh, in my event binding.
That's what I'm talking about. Like, you can't, like, what I was just thinking, that's the problem. If you had a weak map that you could just put every function, like every callback, like every callback during event binding that source list or that target list does on source list, if you could put all those functions in a weak map, but then be able to, when an event happens, just iterate through the weak map, call each one, but then when something is garbage collected, it's just poof out of there.
Are you sure you can't iterate over weak maps?
Yeah, you can iterate. That's what makes them weak.
How weak?
That's not what makes them weak, right? What makes them weak is that
that's what allows them to be weak, right?
I mean, you can get past that by just maintaining a separate array of like keys.
You could maintain an array of keys, but then that array of keys leaves.
Yeah.
Right. But it's like, so the question is if we have finalizers, if I think we can pull this off. I think we have finalizers.
What'd you say, Matthew?
So can you keep a weak map of keys?
You still need to iterate through it, though. No matter what, you need something that you can iterate through. And yes, finalizers would fix this, but I don't know of anything else that would.
Yeah.
That sucks. Oh, now I'm sad.
Nothing like bringing you up before taking you down.
Oh man, you had me so high too. I could touch the sky. I was right there. I was like, what was his face? I flew too high and my wings burned. Prometheus. God.
No, wait, the person?
Yeah.
No, Prometheus is the Titan. You're thinking of my damn it.
Getting off into the sci-fi weeds here.
Who flew too high, like with his max wings or whatever, and they melted?
Damn it.
Do you not remember that?
Yeah. Hold on.
Icarus,
thank you, Icarus.
All right.
Yeah. Max wings, yeah.
Yeah. I'm Icarus.
No, Prometheus is the liver guy with the eating of the liver and by the bird. And it's great stuff.
Cool. Anyway, okay.
Yeah.
I think that's it. Is there anything else
No, I think this has been a really interesting conversation. It's going to be interesting to see how this works into CanJS, how it works into Define, what the demo is like. I think you're getting, last time we talked about this, Josh, you were still unsure of what the perfect demo is, but I think you're getting closer. So
this is a good one. I think there's going to be a couple, I met with some folks. I met with the author of RxJS, actually the whole Reactive family of things. I met with him over dinner, and And he threw some ideas at me. Now, obviously, he's more used to kind of the pure FRP approach, where it looks more like jQuery code, where you have all these handlers all over the place. And it's okay. It's still better than like just plain jQuery. But he's interested in how we're trying to hook it into CanJS and into an MVC model as well.
Yeah, I mean that's the define plugin, right? I mean, how
Yeah.
we can translate FRP into. I do think. I mean, FRP is great, but it's not as the things it builds aren't as. They're like little tools versus like macroscopic. Here's a model, which is kind of something easier for
I think it's a lower level tool for building
Yeah.
much more complex things. And he did point out a few things that I found really interesting that I hadn't thought about before. For example, he talked about how it's really easy to mock, to take an application that you have, and simply switch out the source of the events, and then mock those events. So it's very easy to start testing things because you don't have to like do a mock DOM. All you really do is you make a mock DOM stream and spit out these very simple objects for your test.
Mm-hmm.
You just go into your control, and instead of having to like do mock DOM and give it a fake element to hook into and then have that element fire things, all you do is you give it a stream that replaces the source of those events, and you can test all your code that way. Just by mocking the streams themselves. I think that's really compelling. He talked about debugging is also really nice because you can pipe. So one thing that you may or may not have run into is in JavaScript, because and I've been running into this a lot with the Can Compute stuff. Now JavaScript is a very asynchronous language. It has like asynchronous up the wazoo, and one effect that has is it makes debugging a lot harder because you no longer have a meaningful stack, right? So in a synchronous application, an error happens, you look at the stack, and you can kind of understand how it got there. If you get an error in CanJS or really any other event-driven system, what you're going to get is tons and tons of internal event plumbing. And you're going to have no idea what triggered that event because it's going to be somewhere in data, somewhere hidden in all that stuff. Because unless you know it intimately, you're not going to know why. Now, when you start using streams, it's very easy to log out the event pipeline and see it in the order that the event pipeline is happening. And it's very easy to just spit out these streams and filter them and pipe them all into one big thing. And so I kind of want to put together a demo so that makes a little more sense. I had to wrap my head around it a little, and I still don't quite get it, but it seems compelling to be able to then kind of restackify all this asynchronous stuff. Make it, say, even interactive, because you can put debugger statements in these debugging streams. You can combine the streams, filter them, do all these things. So it gives you a lot of power as far as understanding what's going on in your application when you have your events flying around through streams.
Yeah, I mean, I feel like part of that implies that you have a way to combine all of your streams.
And you do. And that's kind of what...
I don't know if you would always in like a very large application, because a lot of those things would be buried in modules that you're not going to like get the... It might not be easy to get like the source event stream. If like this widget's got like a source event stream it's dealing with, and this one, and then they combine those and translate those into other event streams. Well, you might get the output event streams from your two widgets, but then to be able to somehow like get the actual input streams from those two widgets.
That is what I'm talking about, being able to, at a more application global level, being able to start inspecting these event streams, to have it would need more support than simply having a .debug that gives you the value of one event stream.
Yeah, I mean, they'd have to they'd have to publish in some way or export their source event stream.
Well, when we have something like CanJS, it's much easier to do that because we can just have our care that automatically for the user and make it kind of something that happens in the background that they can they can latch onto when they want to or need to.
Yeah.
So we would have kind of like first-class support for, asynchronous debugging of events.
Yeah, I mean, you need some type of dependency injection then to get in there and swap
all
out
this
the
all
events.
this stuff that would be part of like the whole debugging thing. Again, it's like I think it's compelling because the kind of stuff, being able to filter all of these and understand them and kind of poke into them is really cool. And it's something that's very much easier to do when you have first-class things going around instead of just event handlers.
Yeah.
Cool. Yeah.
All right. Well, thanks, Josh.
Excellent. Any
This is
questions? Any
incredible.
concerns?
No, I think a good demo would be like do to do MVC with
Yeah.
a huge ton of objects and show that you can change it and it's pretty responsive.
I could even do it without a single source list. So yeah. Another thing. I have moved for those who have been tracking. If anyone has been tracking the various event stream projects, there's 4. There's CanDataView. I'll write them in here just so people can actually. It's the one I presented. There's also can.eventstream, can.rx, which is rxjs, and can.bacon. So all of these are now available under the Bitovi group.
Nice. You should put that in as the comments to this. Like go to the actual Hangout page.
I don't know how to do that. But
I can send it to you.
Yeah, maybe. Yeah, thank you.
Go to CanJS's Google Plus page, and it should be right there.
Yeah. So all that stuff is moved to Bitovi. It's transferred, so old links will stay. Like if you go to Psychopomp, you'll just get redirected. And that's that.
Cool. Awesome.
Available. All of these except CanDataView are available in Bower and NPM.
Cool. I'm just glad I said Prometheus instead of Oedipus.
Oh boy.
Well, unfortunately, I thought you were talking about the movie, so
Comparing myself to
took me a while.
Greek mythology. All right. See you guys.
Bye bye.
Hey, thanks everybody for watching. We're gonna have another very special CanJS Community Hangout next week. Someone's gonna tell us about their experience with building a CanJS app, so make sure you come for that as well next Friday.
Thanks, Matthew.
Have a good weekend, everybody.